True or false? I heard it true, and that is the right answer. Got two constant growth stocks, same price, same required rate of return. Who wants to hazard a guess? What are the two components to the return on stock?
Dividend yield.
Dividend yield and capital gain yield. So those two added together gives you the total return on the stock. So if two stocks are identical, they have the same total return. What can be different? If the sum is the same, what happens if they've got different components?
B.
Exactly, B. Tell me, that's the right answer. Tell me why you said that.
Because since they both equal the same amount, the only way that they can be different is if one is higher on the capital gains yield and lower on the dividend yield.
Or vice versa.
Yes.
That's right. That's the precise answer. Two stocks have got the same in every way. They have the same required the same expected rate of return. It is possible for one to have a higher yield on the dividend side, but then it must have a lower yield on the capital gain side, or the dividend growth side. So B is the correct answer. Two stocks are identical in every way, the same price, the same required rate of return. They do not have to have the same dividend yield. They do not have to have the same growth rate.
George, could you just go over again the mathematical relationship between the lower dividend growth rate and that also corresponding to a lower capital gain yield?
So this stock has got a required and an expected rate of return of 16%. So the dividend yield is the $2 divided by the $33.33, which gives you 6%. The capital gain yield is the price a year from now, which is we expect to be $36.67, minus the current price of $33. That gives you 10%. So this stock has a dividend yield of 6% and a capital gain yield of 10%. There could be an identical stock, the same price, same 16% required rate of return, that's got a dividend yield of 10% and a capital gain yield of 6%. They both have 16%, but the components are different.
Is dividend growth rate the same, another term for capital gain yield?
It's the growth rate, yes.
Okay.
The capital gain yield is the growth rate applied to the dividends. In other words, the current dividend times 1 plus the growth rate equals the capital gain yield. Okay, if we go back to the last problem, is that true or false?
Oh, back to what you said though, is that always the case where the EG equals the capital growth yield?
The growth rate, yes. That's always the case in that model. Why is that true? Why did you say false?
Because you can put a 0 growth rate into the model.
Yeah, in fact, you can have a negative growth rate in the model. This is a Chapter 7 model. It's got all the calculations that I've just gone through. So again, here's the $1.82, the 10%, the 16% required rate of return, and the arithmetic to calculate the 33.37 that's in the textbook. We switch around the formula to get it into the expected rate of return formula. We observe, because this is actually a more useful one, because we observe the current price today of 33.33. We can then calculate that the expected return is 16%, the dividend yield is 6%, which means the capital gain yield has got to be 10%, which is the growth rate. You also use the model to look at the expected growth rate 5 years from now. Just essentially the expected stock price here is $33.33. All we then have to do is multiply it by 1 plus the growth rate to the 5th power. So that's all this is doing. It's taking this current price times 1 plus the growth rate to the 5th power. 5 is in the 331. Yeah.
I just have a question from earlier. You mentioned how when it gets closer to when the dividend is going to be paid out, the price goes down. But I thought that it would have gone up because if you buy it, then you're going to get a dividend soon. So I guess I'm just trying to explain or understand that. I don't know if you could help give some insight on that.
If let's say the true value of the stock is $30, the long-term value of the stock today, the day before it pays $1 dividend, what will it be selling for?
The day before it pays $1 dividend?
It has to be $29.
Yeah.
Because otherwise, I'll be able to, if I paid $30 today and I get $1 dividend tomorrow, I could buy the stock today for $30, sell it tomorrow for $30, and pocket the $1 dividend. Easy money.
Yeah.
Well, easy money doesn't exist in capital markets. The dividends, the common shareholders know that the dividend is going to be paid on this date. Therefore, I'm not going to let you earn an easy buck. The price of the stock will go down until the anti-dividend price plus the dividend will equal the ex-dividend price. It has to. You can't have assets selling for different prices in the same market. Anyway, that's an institutional detail I wouldn't worry about. The one thing I did not talk about, which I'm going to ask you to do a little today, is non-constant stock valuation. Essentially what this does, and you can read this when you're doing the case. What this means is that suppose you have a stock that's going to grow, for example, like Facebook, might grow for 10% per year for the next 4 years. And then after that, investors think that the growth rate will taper off to, say, 4% per year or 5% per year. You can use the model to model in a chapter to value that stock. Because essentially what you're going to be doing is you're going to get different dividends. These dividends are growing at 10% per year. And then from year 4 after, it'll grow at a lower rate per year. So the way you handle that is you find the present value of the first 3 dividends, you sum that, you find the present value of the terminal value, which is up here. So you use the constant growth model. Again, you can look at the cell addresses in the model to calculate what the expected price is going to be. So essentially, you're saying you find present value, the first 3 months, the first 4 dividends here, and then you find the present value of the dividends forever after year 4. So let's just quickly have a simple example that you have not seen this before, so I'm going to ask you to take a shot there.
Calculate common and preferred.
Beg your pardon?
You calculate common stocks and preferred stocks together.
Yes, I haven't talked about preferred stocks because, frankly, they're not used in healthcare very much. So I can talk to you offline about it because it's not as relevant to this discussion. So we've got Thames Incorporated. It's got a recent dividend of $2.40 per share. In other words, D0 is $2.40. Expected to grow at 6% per year. Risk rate's 5%, and the expected return on the market is 9%. The company's beta is 1.3. What's the expected value of the stock today? Expected price of the stock today? Do you have your hand up? Do you have a number?
Yes. I got negative 5.1.
Negative?
Yeah.
Let's see if we've got some other answers. Robbie.
$60.48.
That's close enough. I'll put the answer up here and you can narrate, Aunt Robbie. So what did you do?
I took today's dividend and multiplied it by the growth rate to get the expected dividend 1 year from today.
Yeah.
And then divided that by the required rate of return, which is the return on the market minus the risk-free rate, which is 4%, times the market beta of 1.3 added to the risk-free rate. And I got 10.2 for that. And then you subtract the 6% growth rate, so you divide the 254 by 4.2%.
So that's the exact arithmetic that I did here. So everybody follow the basic concept here. We're calculating using the security market line, just like we did in Chapter 4. Calculate the required rate of return on the stock. The numerator is today's dividend times 1 plus 6%. That gives us the projected dividend 1 year from now. And we divide it by the required rate of return minus the 6%. And that gives us $60.57. That is the expected price today. If the actual price today was selling for $50, we would if it's selling for 50 and we think it's worth 60,
Are we buying?
we would buy the stock today. If it is really currently selling for 70, we would not buy it because it's already selling for more than what we think it's worth. Any questions about the arithmetic here? The last thing, just to point out quickly, there are lots of sources about the not-for-profit sector. This is from 2011, the most recent data. Again, it shows, it's kind of interesting, it shows how the, except for a slight, that the 2002 recession actually had a much bigger dip in Americans' charitable giving than in the recession of 2008 and 9. We're actually now back on the up curve, up slope. But this tells you that essentially Americans give a lot of money to health care. And it's an important source of capital to not-for-profit healthcare organizations. Okay, any final questions or issues about equity? Okay, let's take a break. And we'll have risk assessment test.
Chapter